Hello. So this lesson is about the second law of motions. We already discussed the theory part. This is about the numericals. Most of the questions will be based on F equals to ma formula. So let's start the lesson. The first question says, how much net force is required to accelerate a 1000 kg car at 4 meter per second square? I repeat, how much net force is required to accelerate a 1000 kg car at 4 meter per second square? So we'll use the formula F equals to ma, force equals to mass multiplied by acceleration. So here acceleration is given, acceleration a equals to 4 meter per second square, mass m equals to 1000 kg. What will be the force? So F equals to ma, and if we put the values of mass and acceleration in the equation, we get F equals to 1000 into 4 Newton. Newton is the unit of force, Newton is the SI unit of force, hence F equals to 1000 into 4 Newton equals to 4000 Newton. That will be the answer of the first question. If you want to write down anything, please pause the video and write it down and then move on to the next question. The second question, if you apply a net force of 3 Newton on 0.0 kg box, what is the acceleration of the box? If you apply a net force of 3 Newton on 0.1 kg box, what is the acceleration of the box? So they have given the force, that is 3 Newton, the mass 0.1 kg, what will be the acceleration A? So we know F equals to ma or A equals to F upon m. We can write this equation as A equals to F upon m, force upon mass. So if we put the value of force and mass, we get acceleration A equals to 3 upon 0.1 meter per second square. We all know that meter per second square is the SI unit of acceleration. Hence A becomes 30 meter per second square. Hence after solving it, A becomes 30 meter per second square. Third question, a body of mass 1 kg undergoes a change of velocity of 4 meter per second in 4 seconds. What is the force acting on it? A body of mass of 1 kg undergoes a change of velocity of 4 meter per second in 4 seconds. What is the force acting on it? So there was some kind of initial velocity and there is some kind of final velocity. We don't know the initial velocity or the final velocity, but we know the change in the velocity. The change in the velocity is denoted by delta v. Any kind of change is denoted with delta. When you will do more exercises, you will get to know about it better. So change in velocity is denoted by delta v, so that is 4 meter per second. So it is the difference of the initial velocity and final velocity. We know that initial velocity, the difference between initial velocity and final velocity, when divided by the time, we get acceleration. When the difference between the initial velocity and the final velocity is divided by the time, we get acceleration. So we'll put that into this solution also. So time taken is 4 seconds. The time taken is 4 seconds. Mass of the object is 1 kg. We don't know the acceleration. We don't know the force. But as I told you that we know the change in velocity. If we divide it in the time, we'll get the acceleration. So acceleration A equals to change in velocity by time. Change in velocity by time. So we know the change in velocity, which is denoted by delta v. Delta v upon t. Delta v upon t, change in velocity by time, delta v upon t. If we put the value there, so 4 upon 4 meter per second square, 4 upon 4 meter per second square, and if we solve that, we get 1 meter per second square. So in the screen you can see that ms, in one unit it is written as m s to the power minus 2, and in the other unit it is written as m per second square. Both are same. We can write it in this both format. We can write it write the unit in both this format. We can write m s to the power minus 2 or meter per second square m slash s to the power 2. That is also there. So we know force equals to mass into acceleration, force equals to mass into acceleration, and if we put the value of mass and acceleration, if we put the value of mass and acceleration, we get the value of force. So the value of mass and acceleration both is 1, so 1 into 1 Newton, unit of force Newton, so it becomes 1 Newton. So that is the answer of the third question, 1 Newton. So today we'll learn a formula that you haven't learned yet, that is V equals to U plus AT. V stands for velocity, the final velocity, U stands for initial velocity, A stands for acceleration, and T stands for time. So we can say that final velocity is equal to initial velocity plus acceleration into time. Final velocity equals to initial velocity plus acceleration into time. But if there is any kind of rest, or if the motion is ceased or stopped at a point that when the motion there is no motion, we say it is 0. So if a body is starting from rest, the initial velocity will be 0, or if a body is stopping after putting some kind of deceleration onto it, then it becomes and it's stopping, then at the end, it because it is not moving anymore, it is at rest, it is also 0. So anything that is related to rest will put the value 0 there. So once again I'll tell you, V equals to U plus AT, final velocity equals to initial velocity plus acceleration into time. For rest we write velocity equals to 0. For rest we write velocity equals to 0. This rest can be in initial velocity or final velocity. As we move on with the problems, we'll get to know them better. In this question, in this fourth question, we'll apply the formula we just learned. So the question is, if a net force of 7 Newton was constantly applied on 400 gram object at rest, how long will it take to raise it to the velocity of 8 meter per second? Sorry, 80 meter per second. If a net force of 7 Newton was constantly applied on 400 gram object at rest, how long will it take to raise its velocity to 80 meter per second? So what they have provided force, that is 7 Newton, mass, that is 400 gram. We will convert it into kg because the SI unit of mass is kg, because SI unit of mass is kg. We will generally try to convert into the similar units. That's how we will get right answers. So initial velocity is 0, as I told you earlier, that if anything is starting with at rest or anything to do with rest, the velocity becomes 0. When the velocity becomes 0, only then it is at rest, that object is at rest. Final velocity will be 80 meter per second. Final velocity will be 80 meter per second. We don't know the acceleration, we have to find that. A equals to question mark, and we don't know the time, so T equals to also question mark. So we know F equals to ma, and we'll quickly put the values there and we'll get the solution. So F equals to ma, so A equals to F upon m, A equals to F upon m. If we put the values of F and m, so A equals to 7 upon 0.4, 7 upon 0.4, and A becomes 17.5 meter per second square. A becomes 17.5 meter per second square. Now we'll apply the formula we just learned. V equals to U plus AT. V equals to U plus AT. So we can write it like this also. V minus U equals to AT, and T equals to V minus U upon A. T equals to V minus U upon A. So V equals to AT, V minus U equals to AT, T equals to V minus U upon A. Since it is starting at trace, the value of U is 0. So we'll put the rest of the values. So T equals to 80 minus 0 upon 17.5. T equals to 80 minus 0 upon 17.5. So it becomes T equals to 18 T equals to 80 upon 17.5. T equals to 80 upon 17.5, and T equals to 4.57. T equals to 4.57. We all know that the unit of time is second. The SI unit of time is second. So if you want me to say it again, I will say it again. V equals to U plus AT, V minus U equals to AT, T equals to V minus U upon A, T equals to 80 minus 0 upon 17.5, t equals to 80 upon 17.5, t equals to 4.57 second. So that's the answer. So the fifth question, a driver accelerates his car first at the rate of 4 meter per second square and then at the rate of 8 meter per second square. First at 4 meter per second square and then at 8 meter per second square. Calculate the ratio of the forces exerted by the engines. So you have to calculate the ratio of the forces exerted by the engines. The forces here means the first time he put some kind of forces of some amount of force so that the car produced 4 meter per second square acceleration, and in the second scenario the driver put some amount of force so that the acceleration produced was 8 meter per second square. So two times the driver put some kind of force, some amount of force, and two acceleration was generated in two scenarios. The first one was 4 meter per second square and the second one was 8 meter per second square. We don't know the mass of it, but it does not matter because I have to get the ratio. So eventually when you will see at the end of it that it is not that important, because even if you don't know the mass in any kind of questions which is related with ratio, many of the terms or the variables get omitted or cut off. So mass is m. The first acceleration a1 equals to 4 meter per second square. The second acceleration a2 equals to 8 meter per second square. We have to find the ratio of the force applied first, that is F1, and the force applied second, that is F2. So we have to find the ratio of F1 is to F2. So F equals to ma, but in this case because there are two scenarios, we will call the first one F1. F1 equals to ma1. The mass remains same but the acceleration changes. So if we put the value m into 4, the first acceleration was 4, so it becomes 4 m Newton. And for the second, similarly, if we call it the force F2, then the formula becomes F2 equals to ma2, the second acceleration which was denoted with a2, the value of it was 8. So the value becomes m into 8 Newton, that is 8m Newton. So if you get the ratio of it, F1 is to F2 equals to 4m is to 8m. So m and m will be omitted, m and m will be cut off. So now and if 4 and 8 both are multiple of 4, 4 1s are 4, 8 2s are 4 1s are 4, 4 2s are 8. So if we just make it in the simplest form, it becomes 1 is to 2. So the ratio becomes 1 is to 2. So that is the answer. The ratio of the forces exerted in the first and second scenario is 1 is to 2. Please write it down. In this question they have given a table and we have to fill in this table. So the mass is constant in this table and the acceleration is also constant. So what changes? The time changes, and due to which the momentum and velocity changes. But before that, let me read out the sixth and the last question for today. A particle of 20 kg is moving in a constant acceleration of 2 meter per second square starting from rest. So particle of 20 kg is moving in a constant acceleration of 2 meter per second square starting from rest. What will be its momentum and velocity according to the table given next to it? What will be the momentum and velocity according to the table given next to it? So the time given is 1 second, 1.5 second, 2 second and 2.5 second. So we have 4 scenarios, 1, 2 and 3, 4, and we have to denote each scenarios with 1, 2 and 3, 4 suffixes. So we'll see how we'll do that. Everything will go in subscript. The 1, 2, 3, 4 will go in subscript for each scenario. When I'll explain it, you will understand it better. So mass equals to 20 kg, m equals to 20 kg. It is starting from rest, so it is u equals to 0. Acceleration equals to 2 meter per second square. So there are 4 scenarios, and for 4 scenarios there are 4 times. So we have denoted each time with one suffix, t1, t2, t3 and t4, which are written in subscript. So t1 equals to 1 second, t2 equals to 1.5 second, t3 equals to 2 second and t4 equals to 2.5 second. So we have to find the velocity in 4 scenarios, which are v1, v2, v3 and v4, and also the momentums, which are denoted with p1, p2, p3 and p4. So today we learned a new formula. Today we learned a new formula, that was v equals to u plus at. Final velocity equals to initial velocity plus acceleration into time. Since it is starting from rest, so the value of u will be 0. So the formula becomes v equals to at. V equals to at. So if you put the value of a and t, which is provided in the question, we'll get the velocity in 4 scenarios. So the first one is v1 equals to 81, v2 equals to 82, v3 equals to 83, v4 equals to 84. Now we'll put the values in there. So for all the scenarios, the acceleration remain unchanged, that is 2 meter per second square. So v1 equals to 2 into 1, v2 equals to 2 into 1.5, v3 equals to 2.2 and v4 equals to 2 into 2.5. So v1 equals to 2 into 1, v2 equals to 2 into 1.5, v3 equals to 2 into 2 and v4 equals to 2 into 2.5. So v1 will be 2, v2 will be 3, v3 will be 4 and v4 will be 5. So now we also have to get the momentum. So momentum is the product of mass and velocity. Momentum is the product of mass and velocity. So we already know the velocity and the mass is constant, so it will be similar like before. So p1 will be mv1, that is mass into first velocity, p2 equals to mass into second velocity, mv2, p3 will be mass into third velocity, mv3, and p4 will be mass into fourth velocity, that will be mv4. So if you put the values here, so it will be p1 equals to 20 into 2, 2 is the second velocity, p2 will be 20 into 3, 3 is the second velocity, p3 will be 20 into 4, that 4 is the third velocity, and p4 will be 20 into 5, 5 is the fourth velocity. So p1 will be 20 into 2, 2 is the first velocity, 3 is the second velocity, 4 is the third velocity, and 5 is the fourth velocity. And so the p1 will be 40, p2 will be 60, p3 will be 80, and p4 will be 100. So write it down. Keep your brain calm, otherwise you will make silly mistakes. So I hope you have understood this lesson, and so practice it well. So today we solved few numericals on the principle of the second law of motion by Sir Isaac Newton. So if you have any doubt, please ask me. Practice them. I will send you few questions to solve at home, and you send me the answers and I will check them. And but most importantly, abide the rules that the government is asking us to do during this lockdown. Don't go outside your house. Try to stay indoor. Wash your hands again and again. Don't touch your nose, mouth, anything, and use sanitizer. But don't stop studying. So thank you.